Hello there, my name is Jawad from Jadid Institute. Today we're going to solve Cambridge IGCSE Mathematics paper 2-1 from May-June 2020 session. It's 1 hour 30 minutes long, 70 marks in total. And make sure you read the instructions before the exam date, right? While practicing your past papers, sit down, spend a couple minutes understanding these rules. The main one here is give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angles where there's when the answers are not accurate, of course, when they're non-exact, unless a different level of accuracy is specified. So what if they specify 2 decimal places in a question? In that case, of course, don't follow these rules. But when it's not specified and the answer is non-exact, in that case you would just use 3 significant figures or 1 decimal place. All right, in case of angles. For pi, just use your calculator, in my opinion. Of course, don't sit there and start writing 3.1424 pi, right? In my honest opinion, just use pi in your calculator. Alright, let's begin. Question number 1. Rectangle A measures 3 by 8 centimeter length and breadth. 5 rectangles congruent to A are joined to make a shape. So 5 triangles congruent. By looking at this, you can say congruent means all of them are exactly the same, right? Congruent, that's what congruent means, when shapes are exactly the copy paste of one another. Now we know that this is 8 centimeter long, each of these longer lines, and each of these dotted lines are 3 centimeter long. Don't get it wrong, don't say these are 3 centimeter long, because if you think about it, look, from here till here it's 8, isn't it? That's what we know. That's 8 centimeter. That's what's shown here. And we know this dotted line is 3 because you see this is part of that rectangle over here, isn't it? So that's gonna be 3, the dotted line. Now what does that tell you? This plus this equals what? 5, isn't it? That's gonna be an assumption, assuming they're equally away from each other. It's gonna say 2.5 here, 2.5 here. We know, add it up, it's 5, right? So yeah, both of them must be 5 when we add up. 8 minus 3, that's 5. That's now since we know that, let's try to add up everything. Let's try to label this. Maybe you can say that's 8, that's 8, that's 8, that's 8, that's 8, that's 8, and these are 3 each, right? I'm getting that from here because they're part of that rectangle. You see, this is not one of the sides. We don't know if this makes a full rectangle. Actually, it doesn't, right? So we cannot say that is 3, right? We cannot say that. However, we know that is 3, so the remaining, these 2 are essentially 5. Like 2 of these are 5, 2 of these are 5, and 2 of these are 5, right? And also this is 3 and this is 3. Now, of course, try to add all of that up. You will get the perimeter of the whole shape. Oh, we forgot this one, so that's also there. When we add up, we get 86, right? Add all of that. 8 times 1, 2, 3, 4, 5, 6. 5 times 1, 2, 3, 4. 3 times 1, 2, 3, 4, 5, 6. Add all of that, you'll get 86. Let's move on. Find the highest odd number that is a factor of 60 and a factor of 90. Alright, so for this one, you may have to do some trial and error. There might be some other ways, but in my opinion, that's one way to do it. You don't need an even number, you need an odd number. So I have thought about it, and to me it seems like 15 is the answer, right? Because 15 is the only odd number, the highest odd number that comes in, which is a factor of 60 and 90. So 15 times 4 is 60, 15 times 6 is 90, right? I don't see any other odd number higher than this. Well, there's 30, which comes in both of them. That's the highest common factor, I believe, which comes in both of them. But it's an even number. It's not an odd number. So 15 seems like the only answer. Mrs. Salman gives her class 2 mathematics tests. Okay. The scatter diagram shows information about the marks each student scored. Write down the highest marks scored on test 1. Look at the test 1, the x-axis, see where the highest marks is, where you know, the furthest cross. Okay, seems like that's the second last over here. And if you divide that, you see, if you divide this 10 by 5 boxes, you're gonna get that each of these equal 2, right? Each of these little units equal 2 marks, right? So that's 2, 4, 6 marks. Write down the highest mark, so that is 66 marks, alright? Write down the type of correlation shown in the scatter diagram. Looks like a positive, right? We have either positive or negative. There's also strong positive and weak positive. This one looks like strong positive, but we can just go with positive, right? Positive correlation. Draw a line of best fit on the scatter diagram. So let's try our best to just draw a line over there. Let's see. I'm gonna be a bit inaccurate. I'm gonna admit that because you know, I do not have a real paper and pencil. I'm drawing it digitally, which makes it a bit complicated, obviously. Alright, I think that's my best estimate. You know, a line that approximately tries to balance on the, you know, the points on each side, right? Approximately. Next, use your line of best fit to find an estimate for his mark on oh wait, I didn't read the first part. Hamish scored a mark of 40 on test 1. Alright, if you realize this shows correlation, so we can guess what Hamish would get. You know, we have a trend here, you see. So we've got a trend here. So if somebody scores a certain marks in test 1, they would score a certain mark in test 2, right? So, and it is a very strong relationship. So we can take a good guess what Hamish would score on test 2 based on the marks on test 1. Hamish scored 40 marks on test 1, and he was absent for test 2. We need to, let's say, estimate his mark. So how are we going to do that? Well, 40 marks on test 1, it's there on the line of best fit over there. Let's look at let's read that on the test 2 line on the y-axis, right? Well, it seems like that is 49, right? So our estimate is it's 49. A bag contains blue, red, yellow, and green balls only. So these are the total number of balls, right? Total possibilities. We can either get a blue, red, yellow, green. No other possibilities, right? A ball is taken from the bag at random. The table shows some information about the probabilities. So we have probability of getting a blue, red, green, but yellow is missing. We can say that's X for now, right? Complete the table. We know that it has to equal to 1 when we add them up, right? The total must be 1. That's what it is. Like, that's how it is. If we have, if these are all the possibilities, they must equal to 1. Calculate, complete the table. So well, for that one, get, you know, just do 1 minus all of that, get rid of all of that, see what's remaining. So 1 minus 0.43 minus 0.2 minus 0.15 gives me 0.22. Another way to do this, well, add this all up, write this as x, do some simple algebra, you will get to 0.22. Abdul takes a ball at random and replaces it in the bag. He does this 200 times. How many times does he expects to get a red ball? So the chances of getting a red ball is 0.2, right? Or 20%. We can even say that, because 0.2 in decimal converted into percentages is 20%. Anyway, we can deal with this. We can even deal with this. We don't have to convert that into percentage. Anyway, so 200 times. Each time the chance is 0.2. So let's multiply by 0.2. The answer is going to be 40. The nth term of a sequence is 60 minus 8 times n. Find the largest possible number in this sequence. Look, so we have to first identify like which n or which term will give us the largest possible answer basically to this sequence, right? And to me it seems like if you take 1, actually that will give you the largest number. All other possibilities will give you a smaller number, right? Let me give you an example. So 60 times 8 times the first term, and replace that with the first term, that's going to be 52 if you check that. If you keep increasing the term, if you go to second term or third term, if you notice, try doing that, you will get lower and lesser here. You'll get lower and lower number, right? Here are the first 5 terms of a different sequence. Find an expression for the nth term of this sequence. Alright, so this seems like an arithmetic sequence. If you notice, the common difference is 7, 7, 7, 7, right? Now there's a method to do this. There's a sort of a formula to do this, which goes like this: a1 plus n minus 1 d, where a1 is the first term, d is the common difference, which is 7 in this case, and then you just go ahead and solve it, right? That will give you the nth term, expression for the nth term. So the the value of n, the nth term, equals all of that. The first term here is 12 plus n minus 1. You don't replace n and 1. And d is, the common difference is 7. Let's try to simplify this. It's going to be 12. 7 times n is positive 7n. And 7 times negative 1 is negative 7. The final answer, 7n. 12 minus 7, which is just 5. That's it. This one we'll write here, 52. Next question. Okay, question number 6. The diagram shows a trapezium. Work out the value of x. Right, we see a set of parallel lines, and we see a transversal, right? And you should know the co-interior angle rule, right? Allied angle or co-interior angle, which says, when something looks like this, there's a set of parallel lines, there's a transversal, the interior angle given like that would equal 180 when added up, right? So here, so when you add these up, you should get 180. 97 minus 3x plus 69 plus 5x. Since we're adding, we don't really need the brackets. Since we're adding everything, we don't need really need the brackets in this case. Even if you do put the brackets, they'll just be, you can remove them. It wouldn't make any difference. 97 plus 67. Oh, actually, all of that equals 180. Now we'll simplify. 97 plus 69 equals 166, plus 5 minus 3 is 2. 2x equals 180. X equals, let's skip some steps, 180 minus 166 over 2, right? Took the 166, added 166 on both sides, and divided by 2. Final answer is 7. Question number 7. Use this information to write 43048 as 438,048 as a product of its prime factors. Looks a bit overwhelming at first, to be honest, but if you look at it, see, they have broken down the number here between 234 and 1872, and they've also shown you 234 and 1872 as product of their prime factors. So actually, we know that 234 can be written as 2 times 3 squared times 13, and we know 1872 can be written as like essentially we are multiplying 234 with 1872, so we can say all of that multiplied with all of that, right? 2 to the power 4 times 3 squared times 13. That will equal 438,048. And now we can just simplify this. 2 times 2 to the power 4 is, you just add the powers. When you're multiplying with the common base, you just add the powers. So 2 times 2 to the power 4 is 2 to the power 5, right? We're going to assume that's 1. No, we're not going to assume it's actually what it is. 3 and 3 to the power 2, 3 times 3 times 3 to the power 2 times, oh wait, sorry, that is 13. So 3 to the power 2 times 3 to the power 2 is 3 to the power 4. 13 to the power 2. Hope that's clear. Now that's 43804, written as a product of its prime factors. Alright? Just one mark, because you didn't really have to do much here. Without using a calculator, work out all of that. Okay. First we deal with things inside the brackets. So first clear the brackets and then multiply with 6 over 25. Well, firstly, convert this into improper fraction. 2 3s are 6, plus 1 7, that's going to be 7 over 3, minus 7 over 8 times 6 over 25 times 8 times 8 times 3. Why did I do that? To find the LCM, lowest common multiple. We need to put, we need to make them equal, that denominators to subtract or add. So times 8 times 3. At the bottom we have 24. At the top we have 7 times 8, 56, minus 7 times 3, which is 21, times 6 over 25. Next, 56 minus 21 is 35. 35 over 24 times 6 over 25. Numerator multiplied with the numerator, denominator multiplied with denominator. 35 times 6 is 210, and 24 times 25 is 600. And I'm pretty sure we can simplify this further, right? It also says give your answer as a fraction in its simplest form. We can do that without a calculator. Let's see. It seems like 2 is a common factor here, so we can divide both of them by a 2, which will make this 105, which will make this 300. Seems like 5 is now a common. Actually, we could have divided that by 10. That would have been easier. So just, cancel the zeros, basically dividing by 10. And here I see that 3 is common. So 3 7s are 21 and 3 20s are 60. And I think that's the answer, right? Cannot be further simplified. Next, factorize completely. Take the common ones out. In these two numbers, the common one is 7. In the variables, the common one in both of them is a. Took that out. Now 7 times what gives you 21? 7 times 3 gives you 21. 7 times, so we already have an a outside, but there's another a there. It's a squared, right? So we write that a again. Now 7 3s are 21. A times a is a squared. That's figured out. Plus the second part, 7 times 4 gives you 28. A is already there. We don't have to write that again because it's not a square, and we need to write b. So that is 7a, 3a plus 4b. Same thing here. Take the common one out. What's common here? Seems like 5 is common. 5x. No, just 5. Just 5. So take out the 5, and that's going to be 4x squared minus 9y squared. See, the question says factorize completely, and I think we can further factorize this. What comes to your mind when you look at that? We know 4 and 9 are square numbers. We can, and x and y are already squares, right, written in that format. We can also take the square root of 4 and 9 since they're square numbers, and we can write them as squares. And if you remember the there's this factorization method, difference of squares, right? So convert them to square numbers. Let's look at it. So 5 times 2x squared minus 3y squared, right? And now difference of square tells us, just add them once, subtract them once. So 2x minus 3y times 2x plus 3y, isn't it? So that's going to be 5 times 2x minus 3y times 2x plus 3y, right? That's just a rule. That's if you revise the chapter, you will get to know that. It's known as difference of squares. Of course, we can write that here. We should write that here, all of that. And of course I also skipped these brackets because at this point they are useless. You know, if even if I put them here, since everything is multiplied here, you know, this element, and this element, all of them are multiplied, we don't need the square brackets. Okay, let's move on. Number 10, points A, B, C, D lie on a circle. Find the value of x and value of y. Alright, so y is 24. If you have read the chapter, if you have practiced a few questions from circle theorem, you should know, you know, angle is subtended by the same arc, isn't it? And x is going to be what? It's going to be half of this 110. And again, there's a rule behind it, which is angle at the center is double of the angle subtended to the center is double of that subtended to the circumference, coming from the same arc, of course, right? So both starting at the same arc, one subtends to the circumference, one subtends to the circumference, one goes to the center. The center one is going to be twice of that at the circumference. So there you go. Yeah, that's 11. Question number 11. The diagram shows a speed time graph for 90 seconds. Calculate the total distance traveled during the 90 seconds. There are two types of graphs in your syllabus: speed time graphs and distance time graph, right? This one is a speed time, and the speed time graph tells you the distance. The area under this part here tells you the distance in a speed time graph, right? When you look at a speed time graph, this part here gives you the distance, all right? Just to remind you, the slope, the gradient, gives you acceleration, right? Deceleration or acceleration. But that's not the question. The question is about distance. Distance is the area under the line here, right? Under the graph. Now, this is not a shape that we have learned, right? This is some random shape. However, we can break this down into a shape that we recognize. So here we recognize these, right? We can recognize this is a trapezium, and this is a rectangle over here at the bottom, right? Or we can further break it down to a triangle if you like. A triangle, a rectangle, another rectangle. I wouldn't highly recommend that. I mean, that's too many shapes. Simply deal with this trapezium with a set of parallel lines and this rectangle. For the rectangle, it's just 90 times 6. Plus, for the trapezium, it's half times a plus b, right, which is the two parallel sides. 90 plus, from this point to this point, it's 60, times the height. In this case, the height is from 6 to 12. That is 6. (90 times 6, 540). 90 times 6 is 540, plus all of that is going to be half times 6 is just 3. 3 times 90 plus 60 is 450. (540 plus 450 is 990. 990 meters. All right, let's move on to the next one. And let's write here. Never forget to write your answer in the answer column, right? Question number 12. Gamma records the times in seconds taken for a group of children, a group of adults to complete a puzzle. Group of children, and that's the data displayed in the box and whisker plot. This is new, I think, in your syllabus. This is a new topic. The box and whisker plot shows information about the times taken for the children to complete the puzzle. Now let me remind you, or let me tell you that these two lines here, the extreme lines here, it represents the range. The lower range is the higher, like the lower range at the upper range, right? So that is the least possible value. That's the highest possible value in the data, right? These two whiskers, I guess that's what they call it, whiskers. And then let's come to the box now. This is the interquartile range. So this is the lower quartile, the upper quartile, and this is the median, the 50th percentile, right? So that's the zero, like the first one, right? The first or the lowest number, the highest number, the lowest time taken, the highest time taken, the range. This is the 25th percentile of the time taken, the 75th percentile of the time taken, and this is the 50th percentile of the data, right? Find the interquartile range of the times taken for the children to complete the puzzle. Well, let's zoom into that. Seems like each of these boxes represent, since 10 boxes and 20 seconds 20 seconds are represented by 10 boxes, that means each box represents 2 seconds, right? Apparently. So how many boxes are these? Seems to me like these are well, let's count: 1 2 3 4 5 6 7 8 9 10 11. So there are these 11 mini boxes, right? 11 units. Each of them is 2 seconds. 11 times 2, that's 22 seconds, right? Alternatively, you can find this value, if you like, this value, and you can find this value and subtract them. It's easier to do in real life. Like, this might give you a headache. Looking at this might give you a headache, but in real life on a piece of paper, it's easier to track the boxes. The table shows some information about the times in seconds taken for adults to complete the puzzle. Alright, so we have some data about the adults. We're just gonna have to plot that on the graph here. Alright, so minimum and maximum is 28 and 75. Let's see. 28 is 1 2 3 4 5. That's 30. 28 is around here, that one, right? So that is 28. And then we have 75. Well, 1 2 3 4 5, that is 70, and 75 should be right here. Okay, 3 boxes up. Of course, as I earlier mentioned, it's going to be easier to deal with on a real piece of paper. This time, like, I'm drawing digitally, it's a bit inconvenient, to be honest. Next, lower quartile is 42, so that's this one here, the lower quartile, 42, and this is where the box starts. The two ends of the box are lower and upper quartile. 70 is the upper quartile. That's going to be part of your box, right? And the median is 58, which is right here. In the exam, obviously, you're going to use a ruler, right? You're going to use a ruler, a straight edge, so you can get your answers accurately, right? This is not good, I'm telling you, this is bad, right? But in the exam, of course, you will use a straight edge to nicely draw this, okay? Let's move on. Okay, next question is here. Number 13. Work out the radius of the circle. Alright, now how many marks is that? That's 5 marks. I had a guess because, the information is not that straightforward, apparently, right? You need to find the radius, but seems like we do not really have that information directly provided. Let's just study the issue here. Let's study the case. C lies on the circle. Well, they will state the obvious here. I'm aware of that. A, B. Okay, so whatever is given here. Now we just simply need to find the radius. Now, it says that this is the diameter. AD is the diameter. And C is in the circumference. Or C touches the circumference. It lies on the circle. You should know that this is 90, right? That's one of the circle theorem rules. Now, and we know that's 18. If we can somehow find AC, then we can use Pythagoras to, use AC and CD and AD, as A, B, and C to get the diameter. Once we get the diameter, divide that by 2, you'll get the radius. All right. Now, how do we find AC? That's the question. If you notice, there's a topic in your syllabus about similarity, right? These two triangles are similar. because they have all the same angles. If you notice, this angle and this angle is going to be the same. Why is that going to? How do I know that? Well, it's because if you imagine a parallel line, a set of parallel line, a transversal goes through it. This angle and this angle is going to be the same, right? Corresponding angles. So these two angles are the same, these two angles are the same, and this angle, and this, of course, this angle makes up part of both of them. So apparently these two triangles are similar, and we can use some rules of similarity to solve this. What we can do is we can put the corresponding side over the corresponding side, right, and make it equal to the set of other corresponding side. Let me show you here what I'm talking about. AC, basically we'll say AC over AB is going to be equal to CD over BE. If you notice, we are taking fractions here, right? As a fraction, you know, this side or this side should equal this side or this side. It should be same in the proportion because they're similar. Now we can say AC over AB, which is 21, equals CD, which is 18, over 13.5. Now one step and we can find the length of AC. 18 over 13.5 times 21. Let's see what that comes down to. 21 times 18 over 13.5. 28. We have the AC, right? We have the line AC. We have the length of line AC, which is 28. Now using that information, we can say 28 square plus 18 square equals 80 square, right? To find the value of 80 itself, we're going to take the square root on both the sides. We can say 80 equals, let me check, square root of 28 squared plus 18 squared gives me 33.2, or let's just make it 33.3. 80 is the diameter, so to find the radius, we're just gonna divide that by 2. 33 divided by 33.3 divided by 2 gives us 16.65. Or we can, to three significant figures, we can say that is 16 point. Of course, even this is estimated, but even this is rounded off to two decimal places. We can, you know, further round it off to three significant figures, which is going to be 16.7. That's radius. Let's move on to the next one. Number 14. Find the value of P. Alright, so what do we have to do here? It says f of x equals that, g of x equals that, f of g of x equals that. Alright, so essentially let's try to find what is f of g of x, right? So f of g of x is 5x minus 4. So we're going to replace the x over here with g of x. So 4 times 5x minus 4 plus 3. Right, so for x instead of x we write the g of x, because that's what we have to do, right? We have to find f of x, f of g of x. So we plug in the g of x into the f of x. Let's simplify. 4 times 5x is 20x. 4 times negative 4 is negative 16 plus 3. If you notice, we're getting there. 20x minus negative 16 plus 3 is negative 13, and that's the answer, negative 13. Next, find the inverse of h of x. Well, temporarily we can replace the h of x with this with y. Temporarily we can say y equals 5x minus 1 over 3 Now try to make x the subject. You know, multiply 3 on both sides. That's 3y equals 5x minus 1. 3y plus 1 equals 5x. 3y plus 1 over 5 equals x. Basic algebra. And now for the final answer, now you have the inverse. Now for the final answer, just replace that y with x again. I told you y will be replaced temporarily. So 3x plus 1 over 5. Done with that. Next one. Question number 15. P, R, and Q are points on a circle. P, R, Q. Okay. AB is tangent. All right. To Q. At the point Q. QR bisects PQB. PQB, this angle, is bisected by this line QR. Look, bisect means it crosses right through the middle, right? That's what bisect means. So if it crosses right through the middle and that is x, so that's basically, this line actually halves the PQR. So if that's x, that's going to be x. Make sense? So we can already say that this is also x. We can say that because we know it's a bisector. Angle BQR, angle BQR, this one, is x, which is shown in the diagram. And x is less than 60. Alright. Use this information to show that triangle PQR is an isosceles triangle, which means two angles are the same and two sides are the same. Give a geometrical reasons for each step of your work. Well, we need to prove this triangle is isosceles, means two angles and two sides are the same. Alright, so we can say that that is also x. Why can I say that? Because of a rule called alternate segment theorem, right? In which tells us, that's going to be x because this over here is an x. Now, well, we know that this is x and this is x. We can say this makes it isosceles, right? Now let's prove it. Let's give them reasons. So we can say PQR first of all. Angle PQR equals x. So because QR is the bisector. Examiner will understand what you mean by that. And we can say QPR, angle QPR equals x as well, because alternate segment theorem. And well, how many marks is that? 3 marks. And also there's this information about x is less than 60. So we can say, well, okay, the reason this is given to you is to prove that it's not equilateral. If it is 60, then we can say it's it's possible that it's equilateral. So that disproves that, right? X is less than 60. So if these two are less than 60, this must be more than 60, right? This PRQ, and that tells us that certainly this is an isosceles triangle, right? X is less than 60, so can't be equilateral, right? There you go. 3 marks, one each. M is inversely proportional to the square of p minus 1. Okay, so the square of that, m is inversely proportional to that. When something is inversely proportional, we can first of all write it like that. M is equal to k over p minus 1 squared. If it was directly proportional, you would multiply the k in that case. But in this case, you'll put it at the top in the numerator and the other number in the denominator. Now your task. Now since you're given p and m value in one scenario, they will first give you the value of both the variables, so you can find the constant k. Once you found the constant k, then they will take away one of them and they will give you a new scenario where one of them will be missing, right? So let's using this scenario, let's find the value of k, where m is 5 k over p minus 1, which is 4 minus 1 squared. 4 minus 1 is 3, 3 squared is 9. So essentially we can say k equals 5 times 9, which is 45. K is 45. Now we can update this if you like. M equals 45 over p minus 1 squared. Now in this case we have the k, it's constant, it's not going to change for any scenario now. Now we can find m using p and the k that is provided. M equals 45 over 6 minus 1 squared. We replace the p with the value of p. 6 minus 1 squared is 25. 45 over 25 is 1.8. The answer is 1.8. It is inversely proportional. Let's prove that. Well, you see, p increased from 4 to 6, m decreased from 5 to 1.8. That's what inverse proportion means. When one of them increases, the other one decreases, right? That also helps us understand that our answer is probably right? At least the fundamentals are correct, that when p increased, m decreased. That's what inversely proportional means. One increases, the other decreases, right? 17. Find 3m. So essentially 3 times that. You know, in such a case, in a columnar vector, when something's multiplied, when you have to multiply something, just multiply the both of them, right? Multiply the both of them with that number. 3 times 5 is 15. 3 times 7 is 21. That's it. It says vector VW is 10. So essentially this gives you the path, like how, let's say it starts at this point. On x axis is gonna move 10 units, right? And on y it's gonna move negative 24. Now essentially VW means this means find the magnitude or find the length of VW. So if, let's say that is v, that is w, we went from v to w and it took us that path. They're saying find the length of this, right? I think you can already notice it's a Pythagoras, right? That's 10, that's 24. Sign doesn't really matter in this case. That's 10, that's 24. Because it's about the distance, it's about the length. We cannot have negative length, right? So based on that we can say this VW is gonna be, well, if we say, you know, a squared plus b squared, in this case a and b is 10 and 24, equals c squared, get the square root of both, and you know that's simply going to be a squared plus b squared square rooted equals c. In this case c is this magnitude, this length, and like the answer that we need, and a and b are these two. Very repeated sort of question, right? This often pops up in your exams, so make sure you understand how that works, right? Usually the same case but different numbers and different variables, but the same question. So let's replace these a and b. 10 squared plus 24 squared. As I said, sign doesn't really matter because we're talking about distance, we're talking about lengths here. Equals VW. Okay? I've messed it up kind of, but I'm gonna have to fix it. So VW there. Square root of 10 squared plus 24 squared is 26. Done. Question B. We have a parallelogram. O is P and that is Q, alright? E is the point on AB such that AE is 3 and EB is 1. So on that line, if that's 3, that's going to be 1 in terms of ratio. So we can say the total here is 4 because that's 3 up to this point and then 1 over here. The total denominator can be 4, and we can say AE is 3 over 4, 3/4 of that full line, and that's 1/4 of that full line, right? Find OE in terms of P and Q. So now we have to go from O to E. Let's do it. We can go from, to go from here to here, we can go from O to A. So OE equals, first go from O to A, and then go from A to E. Right? Going from O to A, we're going to have to just take a P. And A to E, we're going to take 3/4 of the Q, because you see that whole line is Q. That whole that, you know, from A to B is Q, so 3/4 of that is plus, you know, 3/4 of the Q. And actually that's it, isn't it? It's the simplest form. We cannot simplify it further, I think. So we can just simply say P plus 3/4 Q. All good. Let's move on. Question number 18. P equals 2 times W plus H, where W is 12 nearest whole number, H is also nearest whole number. Work out the upper bound. Now when they say whole number, first we're gonna have to adjust it. We're gonna have to add or subtract a certain number. What's that number gonna be? Well, look at what it was rounded off to. It is nearest whole number, so just take 1/2. That's the number we're gonna add and subtract to find upper and lower bound. If it were one decimal place, we would take 0.1. That's the number we're going to add and subtract to find upper and lower bound. If it was to the nearest 10, it's always going to be with 1, right? So that's the number we're going to add and subtract to find upper and lower bound, right? If it was to the nearest 2 decimal place and 0.005, that would be the number added and subtracted to find the upper and lower bound. In this case, whole number, just a simple 1 divided by 2, 0.5. And that's the number we're going to add and subtract. So since we're finding upper bound and all of that is added and multiplied, the higher it is, the better it is, right? We just need the highest possible number of P. And apparently we're going to have to take W and H as the highest as possible, because logically we'll get the highest possible answer of P if we take the highest possible answer for W and H. So let's add 0.5 to this, add 0.5 to this. Not to the final answer, right? To the workings, because these were the variables that were rounded, not P, right? So if that was rounded, first you have to round it up and then find the value of P. P equals 2 times 12.5, that is W, plus H, which is 4.5. I'll put that in my calculator. 2 times 12.5 plus 4.5 gives me 34. Next question, 19. The diagram shows cuboid A, B, C, D, E, F, G, H. It's pretty long. Almost half of the alphabet's covered. Of length 20 centimeter. The diagram shows cuboid of all of that of length 20 centimeter. The length is 20 centimeter. The width is 5.5, and the volume is given. How do you find volume? L into W into H, right? So we can say length into width into height equals the volume. Find the angle between the line AG and the base of the cuboid ABCD. So essentially this line AG and the base, like that, we're gonna have to find that angle. A very repeated kind of question, right? And apparently I can already see that we can we're gonna need this angle. So I can see that if we can find this height, we're gonna have something, and using Pythagoras, if we can find this length, let's just call it B, right? Just simply call it B. Give it a variable, and we can find this B using, actually it's better to say C. We can say C. So we can find this C very easily by using Pythagoras, right? So we can find the line C, we can find the line H using the volume here, and then we can use SOHCAHTOA, right? Trigonometry for to solve this, right? Sine, cosine, or tan. We'll come to that later. First, let's find H. Well, we know L into W into H should give you 495. To find H, 495 divided by 20 times 5.5. Let's do it. 495 divided by 20 times 5.5 is 4.5. So height is 4.5. Let's find C, the little c here. Well, c is essentially square root of 20 squared plus 5.5 squared. If you like, you can first write the steps step by step, but I've obviously skipped a couple of steps there. Directly jump to the final step. Because we have done a couple of Pythagoras in this paper earlier, we don't have to do that again. Square root of 20 squared plus 5.5 squared. It's going to be 20.7. We can say that, right? C equals 20.7. If you want, you can actually write a few more decimal places, but you don't have to, right? You can. Your answer will be more accurate if you do, but you don't need to really. 3 significant figures are enough. Now, of course, that's obviously not the final answer. For the final answer to find, let's call this x. To find the angle x, we're gonna use SOHCAHTOA. Which one works here? What's the information provided to us? We have the opposite and we have the adjacent. Opposite, adjacent. Which one works here? Tan, right? TOA, if you remember SOHCAHTOA. The sign should include opposite and hypotenuse, and cos should, if you want to use cosine, you're gonna have adjacent and hypotenuse, right? SOHCAHTOA. In this case, you're gonna use this one. Tan x, we're gonna say tan x equals opposite over adjacent. X equals tan inverse 4.5 over 20.7. Well, these are regular steps, right? There's nothing there should be nothing confusing here. If it is, then I guess you'll have to revise the simple trigonometry. Tan inverse 4.5 over 20.7. 12.3. Okay, say 12.3 degrees. Alright. Let's move on. The curve y equals x squared minus 2x plus 1 is drawn on a grid. So we draw that, and we draw a line. We draw some line. The points of intersection of the line and curve are used to solve the equation. Okay. So that line, when it intersects with that curve, it gives us this. It can be solved It can be used to solve this equation. So essentially, this equation is kind of derived from the intersection of that point and this one, right? When this equaled that line, right? The new line that was drawn. When that line equaled this happened, right? We came to this solution. So essentially, what we have to do is we have to make this look like this, because this contains some element of the new line that was drawn. We'll have to get rid of this, put it on the other side, and make this look like this, right? So well, x squared, it matches. This is -2 here and this is -7 here. What are we gonna do? We're gonna add 5x, but if we add 5x here, we're gonna add 5x here as well, right? On both the sides. That's how mathematics, that's how equations work, right? If you add something on one side, you need to add it on the other side as well. And next, to make this final part look similar to this one, it's +5 here, it's +1 here. We minus 4 to make it 1, and we minus 4 here because we cannot just minus 4 from one side. Alright, now if we update this part here, if we update this the side on the left, we're going to get x squared. -7 plus 5 is -2x. That's what we needed. We needed to make it look like that. And 5 minus 4 equals 1. Made it look like that. And of course, we'll have some new things on the right side. And essentially, that is the line that was drawn, right? Because when you make both of them equal, and then now again, if you go reverse and you put that back into this, it would make it look like this. So essentially, the solution of this will give you this equation, right? So y equals the line that was drawn equals this 5x minus 4. That's the line that was drawn. Expand and simplify. Is this the last question? No, it's not. Expand and simplify. We can do step by step. We can expand these two first and then multiply that with this. Well, that's going to be x times x is x squared. X times -5 is -5x. 3 times x is +3x. 3 times -5 is -15. and of course we still have 3x minus 1 remaining. We can simplify this first, and then we'll multiply these both, right? X squared minus 5 plus 3 is minus 2x minus 15. Now essentially, you multiply this with all of them to expand it, and this with all of them. Make it a bit neater. The other ways to represent this, but this is one way to do it, right? So essentially you can rewrite all of that. You can say 3x times all of that. We can rewrite, and negative 1 times all of that, but I'm just going to skip a step and just simply skip to the workings, the final step. 3x times x squared is 3x cubed. 3x times negative 2x is negative 6x squared. 3x times negative 15 is negative 45x. I'm doing this without a calculator. I hope I don't make a silly mistake. Negative 1 times x squared is negative x squared. Negative 1 times negative 2x is positive 2x. Negative 1 times negative 15 is positive 15. 3x cubed, 6x squared, minus, okay, so we have another x squared. We're going to simplify that. Negative 6x squared minus 1x squared, so that's negative 7x squared. So let's start writing the final answer. 3x cubed. 6 plus negative 6 minus 1 is negative 7x squared. Negative 45 plus 2x. Negative 45x plus 2x is negative 43x, and just 15. I think it's a type of question which I don't usually expect. I don't expect. It's kind of a rare question, right? Expanding 3 brackets, right? Normally it's 2 brackets, and it's just for 3 marks. So big chance of making a mistake there. A silly mistake. Even if you're good with this, you may make a silly mistake with the signs. So be a bit careful with this one, okay? Next question, 22. Find the area of regular hexagon with side length 7.4 centimeter. A hexagon is a 6-sided shape, right? We can draw this here. Of course, it's a rough representation of what a hexagon looks like. Not accurate, not to scale. And they all will be equal, right? All the sides are going to be equal because it's a regular hexagon. And it says that each side is 7.4. Now you should know that a hexagon has these triangles, and they are equal. Just a hexagon, not pentagon and other shapes, but the 6-sided shape has these equilateral triangles, right? That's a fact. So a hexagon has these equilateral triangles. In an exam you would draw this, right? To make things easier for you, you should draw this. That's my advice. And we know that is 60 each. And we also know that's going to be 7.4 each, because of course we know it's an equilateral. That's a fact. All the regular hexagons, not every hexagon, regular hexagons, all the regular hexagons are have these equilateral triangles. We need to find area of this regular hexagon, but of course we can use this. We can find area of a triangle and multiply that by 6, because we have 6 of those, isn't it? We have 6 of those triangles. So how do we find area of this triangle? We use the other formula of triangle, not just half. We know that there's not one formula to find area of triangle, half into base into height. No, there's another one, half into a into b into sine c, right? Where the c is like for example, if there's a triangle like that, a b angle c, right? If something looks like that, there's an angle sandwich between a couple of sides. Those sides will be a and b, and then you'll use that as a sign, and that will give you the area of that triangle. Okay, let's find value of a triangle, and actually we can write the final step as well. This is it. This is our answer. Okay, let me just put that in my calculator. Times 7.4 times 7.4 times sine 60. That gives me 142.27. 142.27, all of it, right? And I advise you to first solve this and then multiply by 6. Like, solve this, show the number, multiply by 6, and then give the final answer. So in this case, the final answer is going to be 142. That's enough. 3 significant figures, right? Alright, so that's it. I'm not exactly sure how long it took us. You can look at the video duration. I'll get to know that once the recording stops. And hope you enjoyed the lesson. Please subscribe to the channel for more videos like these and other subjects as well. Take care. Have a nice day.